everyone, so in today's lesson we're going to be learning about relative formula mass, and what you're going to need is your copy of the periodic table. Now you can either use copy that I gave you, your A3 version, your data leaflet that you have, or if you've got your homework diary, remember there's a version in your homework diary. So I just want to start this video off by doing a bit of a recap from atomic structure and what we know about from looking at the periodic table for each element. So this is just sodium as an example. So you know that the bottom number or the smaller number is your atomic number, and if you're not sure what these numbers mean, then please have a look back in your booklet, number 1 booklet, and check you understand them. And the bigger number, or 23 here, is your mass number. Now a key term that you need to understand, and it's written on page 3 of this booklet, is what relative atomic mass means. And the definition is written in your booklet. Okay, because we're going to be using relative atomic mass for all these elements. So in this case, the relative atomic mass of sodium is 23. So whenever sodium is in a compound, we can use the mass of sodium to be 23 to work out what the relative formula mass of the compound is. Okay, that's the whole point of this video, working at relative formula mass of compounds. So another thing that we've already looked at is when we have the formula and what the formula means. So remember, whenever we were doing about the bonding and structure, so for example, if we have a formula that is CO2, that means that there's 1 times carbon and there's 2 times oxygen in it. If we have a formula that is Al2O3, that means that there's 2 times aluminium and 3 times oxygen. So hopefully you remember doing that in our bonding topic whenever we're working out the formula. So we're going to talk about 4 examples like that. How do we work out then the relative formula mass for compounds like that? Okay, so I'm going to start with this first one, just the carbon dioxide one. And I'm just going to move this underneath so we can show you how it's. If you set it out, if you set your working out like this, then it's easier whenever you look back just to check you haven't made any mistakes. So start with the formula, then we decide what is the formula made of. So in this case, 1 times carbon, 2 times oxygen. Then we look at the periodic table and we find where those elements are, and we find the relative atomic mass for those elements. So carbon's relative atomic mass is 12, so we have 1 times 12 for carbon. And oxygen's relative atomic mass is 16. So we've got 2 times 16. A little bit of a sum. So 1 times 12 is 12. 2 times 16 is 32. And then we add them together. And we can say that for carbon dioxide, the relative formula mass for carbon dioxide is 44. Now, it's important to note that there's no units when we talk about relative formula mass. It's just a number. We're going to talk later on in this topic about what we use this for if we're trying to say, for example, measure out a bit of a compound, how much we measure out. So for this lesson today, I just want you to focus on how to work out the relative formula mass. So the other example we had looked at there a minute ago was Al2O3. And I said that there was 2 times aluminium and 3 times oxygen. So again, the next step then, we look to see what is our relative atomic mass in our periodic table. So for aluminium, it's 27. And for oxygen, we said that it was 16. So 2 times 27 is 54. 3 times 16 is 48. And we add those together and we get, we get a 2 and 102. So the relative formula mass of aluminium oxide is 102. Okay, hopefully you're following me so far. So in your booklet, it gives you some examples of how to do this and how to set it out. So in your booklet, you've got an example of copper oxides given in your booklet, and copper sulfate is given in your booklet at the top of page 4. So have a look at that and the working out is done for you. And then at the bottom of page 4, there are 4 questions for you to try to do. So just before you do, or before you move on and do your work in class for today, I just want to go through a couple of examples that are maybe a bit more tricky with you before you do the homework task that I'm setting you this week. So I've got 3 examples to show you. So the first one is very similar to what we've just done with aluminium oxide, only this time it's got 3 elements. So it's sodium sulfate. So it's just a more complicated formula to see if you can work out a formula with 3 elements in it, which hopefully you'll have no problems with because we've done this before in class. So maybe you want to pause the video and try and do this on a wee piece of paper, and then press play again and see if you get the same answer as me. So 2 times sodium, 1 times sulfur, and 4 times oxygen. Okay, so that tells me, looking at the relative atomic mass, let's see if you can find that in the periodic table for each of them. So for sodium, it's 2 times 23. I'm just going to work out the sum while I'm here. For sulfur, it's 1 times 32. And for oxygen, it's 4 times 16. Now, of course, you can have your calculator handy so you can work this out. Or if you don't mind doing mental arithmetic, then you can add it up. So that's a 2 and 7 and 142. So we say the relative formula mass for sodium sulfate is 142. Okay, so the other thing that I want to go through with you then is what happens if we have brackets. So do you remember when we came across compounds like this before, what the bracket meant? Hopefully you do, and you can have a wee go, pause the video and have a go at this example. So the bracket means that everything inside the bracket is multiplied by the number outside the bracket. So in this case, we've got 1 times calcium, then the bracket comes in and we've got 2 times oxygen and 2 times hydrogen. So that's 1 times 40, which is 40, 2 times 16, which is 32, and 2 times 1, which is 2, which gives me a total of 74 for the RFM of calcium hydroxide. Okay, and then the last example I just want to go through in this video, again, you can pause the video once I've drawn the structure out and try it yourself, is one that's zinc nitrate. Okay, so again, we're just trying to get it, can you do it with 3 elements and a wee bit more tricky? So pause the video now and see if you can work it out. Now in this case, because we've got a number inside the bracket as well as a number outside the bracket, it was really just to see, can you cope with that? So zinc isn't in the bracket, so we've just got 1 times zinc. Nitrogen, we've got 2 times nitrogen, because nitrogen's inside the bracket multiplied by 2. And then for oxygen, we've got 3 multiplied by 2, so we've got 6 times oxygen. So looking at our periodic table, we've got 1 times 65, 2 times 14, so that's 65, plus 28 plus 6 times 16, which is 96. Okay, so that's 13, that's 19, 9, 10, and 189 for the RFM. Okay, hopefully you can understand that okay. If you're not, then just rewind the video and have a watch again, or send me a message in Google Classroom if you have any questions. And that should be you ready to do the questions today and do the assignment that I'm setting for homework this week.